Next part in chapter 4, chemical bonding. Lewis structure. At the end of this lesson, you should be able to explain the exception to the octet rule. For example, incomplete octet, expanded octet, and odd number of electron. So exception of octet rule. So remember when we say octet rule, meaning that the electron in an atom must be 8. Okay, so 8 electron, meaning that atom should have electronic configuration of noble gas. Okay, where the valence electron is equal to 8. But there are exceptions for the central atom. Sometimes they can form incomplete octet or expanded octet or odd number of electron. Okay, the first case is incomplete octet, where the central atom has less than 8 valence electron. Okay, the elements that can form incomplete octet are Be, B, and Al, bebal. Okay, bebal. So we seen before, bebal, they are metal, but they can form covalent bond. Okay, beryllium, boron, and aluminium. So for example, BeH2. Okay, so they will bond like this. So hydrogen, we know hydrogen obey duplet rule. So hydrogen, we don't have any case with hydrogen because they already obey their own rule. So duplet. But Be simply does not obey any rule. Okay, so Be has 2 single bond, and each bond contains 2 electron. So total up, Be only contain 4 electron. So 4 electron is less than 8. So meaning that this is not obeying octet rule, and the case would be incomplete octet. Okay, do not have enough to obey octet. Okay, so that one, the first case. Expanded octet. So expanded octet, where the central atom will have more than 8 valence electron. Okay, so more than valence electron. This one only apply on the element in period 3 or higher. Okay, because of the availability of d orbital. Okay, in period 2, okay, period 2, you cannot have expanded octet. So this one needed to be reminded. Okay, so you need to be reminded that period 2 cannot form expanded octet. Only in period 3 or higher. So period 3, 4, 5, 6 can because they have d orbital. Okay. So for example, SF6. So SF6, fluorine, as you can see, each fluorine. So you have 1, 2, 3 pair of electrons around it. So 3 pair meaning that 6 electron, and 1 single bond. So 1 single bond contains 2 electrons. So total around fluorine, you have 2, 4, 6, 8. So all fluorine obey octet rule. Okay, all fluorine will obey octet rule. What about sulfur? Sulfur, you have S. Okay, so sulfur, you don't have any electron dot around it, but you have 6 single bond. So 1 single bond contains 2 electron. So if you have 6, 2 times 6, you have 12 electron around them. So when you have 12 more than 8, this is expanded octet. Okay, more than 8. Okay. Okay, so reminder again. So only period 3 below. Period 2 cannot form expanded. Period 3, 4, 5, 6 can form expanded and octet. So they can choose whether they want to obey octet or they want to obey expanded octet. Doesn't matter. Okay, they are not wrong. But for this element, only octet. If you do expanded, you are wrong. Okay, the last case, odd number electron. So like the name, odd, meaning that the electron is not even number. Okay, so the structure contain unpaired electron. So if even number, meaning that the electron can be paired. But if odd, meaning that there is one electron left behind and it will stay single forever. Okay, so for example, NO, so where you see here the circle with red circle, only contain one electron. Okay, so that is odd electron. Okay, so mostly odd electron number molecule usually come from the group which odd number of group. So 15, 17, group 15, group 17. Okay, so odd number where you see the electron is lonely. Okay, the electron is lonely, is not pair, it is odd.